So we will go ahead and look for how to make domain case diagram, domain model diagrams. So we're not doing use case right now. These are different kind of diagrams. When we say use case diagrams, these are different. These are domain model diagrams. And what we do for this one is we do linguistic analysis. We hunt for nouns, and nouns are person, place, animal, thing. So any person, even name of a person is a proper noun. Common noun is like it could be anything. And then we have place, whatever place it is, whatever animal it is, and then a thing. For example, university is a thing, semester is a thing. It's not an action, it's not a verb, it's not adjective, it doesn't define any quality, so it's definitely a noun because it's a thing, it's something. Then we can say all of these nouns are entities. These represents main concepts of actual classes. Then we have, for example, you read the professor text and identify all the nouns. Once you know the list of nouns, you can clarify them to decide what belongs in the diagram. Nouns belong in the diagram. Then we know that these represents main concepts that will become actual classes. These are actual concepts like account. Then we have attributes. Attributes are things that we can store. So you can think of it this way, that pin is pin entity. It also depends on the question, that if there is a link between this, we have to connect it somehow, then we think differently. But generally speaking, pin is a value that demands integer or something. It demands something from you, and in that case you definitely don't need to give it to entity. It's an attribute that's for example, a variable. Then we have synonyms, things like, for example, banking system and bank system are the same thing, so you don't write it two times. Then you avoid dictionary of terms. You apply dictionary of terms, you translate them into real world. For example, generalized instances. If text mentions a specific person like Peter Winter or T.H. Schaffenberg, you do not make them classes, you generalize them into user. For example, Peter is a user and T.H. Schaffenberg is a university, so you write university. So we flag vague terms. If a term is ambiguous like SSO or other people, it is vague and state assumption you're making to draw the model. So we identify models, we hunt for verbs and phrases. Once your classes are drawn, look at how the text connects them to figure out lines. Is a kind of, is a. So is a is always a generalization. It's always inheritance. It's a solid line going like this arrow on one side, pointing towards the parent. Consist of, cannot exist without. So consist of or cannot exist without is composition. Composition is either strong aggregation, filled diamond, or weak aggregation, unfilled diamond. Then we have is part of or has a, but survives independently. So it uses shared weak aggregation, a hollow diamond. Then we have plain verbs, takes part or owns. For example, we might say it uses a standard association and adds a reading direction triangle. Plain verbs includes that it takes part or owns. This is a standard association adding a reading direction triangle. Then we have cardinality, exactly one is just one. Any number or zero or more. Any number means this, zero or more also means zero to more. Exactly one means one to many. Exactly two means exactly two. At least one, means at least one, and then it can go to as many. Then we need to go forward and look what are the questions that we have to master these concepts. The first question we have is that undergraduate and graduates are kinds of students. A transcript cannot exist without its specific student. A registration for a semester is complex. It consists of student, a course, and a semester simultaneously at the same time. A course explicitly points to a syllabus. It says that a course points to a syllabus, navigate left to right, but syllabus has explicitly no reverse navigability to a course. It's pretty much obvious looking at this what we're doing here. Then we have finally professor is assigned to a course. Now looking at the text, we can identify a lot of things, that this is a noun, this is a noun, this was a relation that we identified, this is a noun, this is a noun, transcript is a thing, student is so we need to look at nouns. We have person, Places, animal and things, for example. Registration is a thing. Semester is a thing. Complex is a concept. It's not a thing. It connects to a student. A course is a thing. A semester is a thing. These are our possible attributes or our possible entities. A course explicitly points to a syllabus. So we have a course explicitly point to a syllabus. So then we just put all of these as, for now, plain as like this, that we need them. So say undergraduates, graduates. But then we know that the first thing we do is undergraduate are kind of students. So we make undergraduate table and then make graduate table and then we connect them together with inheritance to the student. So are kind of student. So student, so undergraduates and graduates are also students. So we know that they are exactly the same as students, but they are also undergraduate and graduate. So they are students. They are students. They are students. These are students. And this is what are kinds of students. So this is how we make the inheritance. Student is going there like this. And then our transcript cannot exist without a specific. Then we go to second. This is something that we don't need to look into. We have student, then we have transcript, and it says that a transcript cannot exist without a student, which makes sense that if there is no student, there is no transcript. Then we make strong aggregation here. So basically after that, then we know that it said that the course explicitly points to a syllabus. So it points to a syllabus navigating left to right, but the syllabus has explicitly no reverse navigability. So a course can only have a syllabus, and syllabus does not have a course. So then we can see that we have open arrow add plus cross, explicitly restricted, and visibility. Syllabus has no visibility back, and then we knew that, but syllabus has no reverse. Finally, then we knew that this registration is a complex. So this is registration. So then we have this diamond with registration because it was complex and it's connected to all of these at the same time. Then we have e-commerce platform, where it said that the physical goods and digital goods are types of products. A shopping cart aggregates multiple products, but the product exists independently of the cart. An order line item, however, is strictly composed within an order and dies if the order is cancelled. The external Stripe system realizes the interface iPayable. Sometimes a product is offered as a bundle component of another product. So what you can do is that you can say, okay, there's a branch. It has a, for example, we know, first of all, make all the nouns here. What's a noun here? Person, place, animal, thing. We have a thing which is branch, we have product, we have physical good, we have digital good. So we know that product is a physical good, product is a digital good, and branch is a product. So we know that physical good and digital good are types of products. So we know that this is the parent. A shopping cart aggregates multiple products. So a shopping cart includes multiple products. We have hollow diamond, which is a weak aggregation. Aggregation means a connection, but means that it can exist independently because it's a weak. So I'm sorry, meaning that it can exist independently. This can exist independently. Weak aggregation means that, but strong means that it cannot exist independently. It needs this. This is why it's strong. Then we have iPayable. We have dash line, empty triangle notation. Realization defines behaviors defined by rules. For example, Stripe system realization is iPayable is a process. Then we have bundle includes a product. The things that we have here are generalization, inheritance, basically, weak aggregation. Then we have composition, strong aggregation, and then we have association. Then we know that physical goods and digital goods are type of products. Generalizations, we use aggregation, multiple products, but product exist independently. Weak aggregation, that they exist independently, so they can mean we need weak aggregation with products. Then we know strictly composed within an order and dies if the order is cancelled. Then we know that a product is offered as a bundle component of another. Then we know that we have smart home network. A house consists of more rooms. If house is demolished, the rooms are destroyed. Smart lights and smart thermostats are kind of smart devices. A room contains 0 or more smart devices. Share aggregation says that devices can be moved to a new house. A smart device can be configured to trigger another smart device, meaning that you have a smart device, it has a smart light, it has a smart thermostat, it has a smart light. Then we have strong aggregation. Room cannot exist independently without the house, that's why it's a composition. Then we have smart device, it has a weak aggregation with the room. And then we have a smart device, which is reflexive association, meaning that association name plus reading direction triangle, a device can trigger and get triggered. Roles applies and cardinalities and vice versa. So it triggers the smart device and vice versa. Now the cues in the prompt in the question was that smart lights and smart thermostats are kind of smart devices, which let us know that it's a generalization. Then consist of one or more. If demolished, rooms are destroyed. We know that this is a composition. Strong aggregation. Fill diamond contains 0 or more smart devices. Devices can be moved. This is a weak aggregation because they can be moved. They don't need to stay there. A device can trigger another smart device. So trigger class relates to itself, meaning that a smart device can trigger another smart device. It can trigger itself. So it's a reflexive association. Then we know that we have a ride sharing app. Drivers and riders are both kinds of app users. The system tracks a ride by linking a driver, a rider, and a vehicle all at once. A corporate fleet aggregates many vehicles, but vehicles can be sold off, of course, independently. The system must navigate from a right to route, left to right, but reverse navigation is undefined. Now you need to model generalization, the n-array association, hollow diamond with no binary lies, and shared aggregation. Then we know we have a staff. It is a app user, and it's a kind of or is a driver or a rider. Then we know that app user is a rider and a driver at the same time, but then we have this n-array relationship where rider tracks must link all at once, rider tracking all at once using n-array connected to the corporate fleet, vehicle, rider, and driver all at the same time. Then we have relationships. We know corporate fleet has on both sides a weak aggregation, and then we have navigation direction, that ride defines a route. So we have navigation, we have n-array, we have composition, we have shared aggregation, and then we have generalization. This is shared aggregation. So weak aggregation, but on both sides. So what we knew was drivers and riders are both kinds of app user. We knew it's a generalization. We know link a driver, a ride, and a vehicle all at once. It's an array association. We link driver, rider, and vehicle together. Aggregates many vehicles, but vehicles all at once basically means an array. And then aggregates many vehicles, but vehicles can be sold off independently. It can be sold off independently, meaning that it's not dependent, which is weak aggregation. Then navigate from a ride to route. Reverse navigation is undefined. This is open navigation arrowhead. So this one, reverse is undefined. So from ride to route. So ride to route, we know like this. It's a navigation. So mags and warriors are characters, and inventory cannot exist without its character. A guild contains many characters. They can leave and join other guilds. A quest assignment is a complex link between a character, a quest, and a specific reward. the player 123 logs into the system. We need to standardize it into a class, combine generalization, composition, and shared aggregation, and an array association. What happens is that Meg is a class. Meg is a kind of character. So we know Meg and warrior are string subtypes of characters. For example, Meg and characters is a relationship. We just like said warrior, and then we know that both of these go to a character. Then we know that we have a hollow diamond going from character to guild, and here we have it on both sides, a strong aggregation. Then we have an array association, again connecting many things at once. Is a complex linking character, quest, reward all at once, just like it was in the prompt. And then we know that in the question, for example, the things that we used were generalization, for example, shared aggregation, composition, an array association, and association. Let's look at the guides that we had. Megs and warriors are characters. So these two are basically characters, which means that they are inherited from characters. Their generalization we need to use. Then inventory exists without its characters. So composition, it can exist without its characters. It's a weak aggregation. It's cannot exist without its character. It's a strong aggregation, which is composition. Basically, it's a fill diamond. Then we know contains many characters, can leave and join other guilds. They can leave and join other guilds. It's a weak aggregation. They are not dependent. They